All right, hi everyone. We're going to be doing Chapter 1, Lesson 2, Complex Fractions and Unit Rates. So as we can see on our doodle notes, that's the title of our lesson right here. So I have a couple of examples of what complex fractions look like. So a lot of times we've seen what fractions look like, right? So if I just cover this up, 1/2. You've seen 1/2 is a fraction. So basically all a complex fraction is we've taken it and added more division bars, okay? We remember that a fraction bar is the same thing as a division bar. It means the exact same thing. So fractions and division bars are the same. Okay, so I have a couple examples of what complex fractions look like. So this is 20 over 1/2. My next one is 1/20 over 1/2. And my third example is 1/2 over 20. So you can have a fraction in the denominator, the numerator, or you can have a fraction in both the numerator and the denominator for it to be considered a complex fraction. So the first thing that we have on our doodle notes is blank blank are fractions with a numerator, denominator, or both that are also fractions. In those two blanks, the first one you're going to write complex, and the second blank you're going to write fractions, because that's what complex fractions are. Okay, so complex fractions are fractions with a numerator, denominator, or both that are also fractions. So complex fractions are simplified when both the numerator and the denominator are integers. And basically all that means is that they're a whole number. Okay, so you don't want to have decimals, you don't want to have fractions or anything like that. Otherwise, they're still considered a complex fraction. So with something like 20 over 1/2, we want them both to look like regular numbers, like we normally would have 20 or 1 or 2 or anywhere up to infinity. Well, how do I go from complex fractions to normal fractions? So in order to do that, I'm going to teach you what's called KCF, or keep, change, flip. Okay? So the first example I have is 1/4 over 2. And usually you can tell where they are based off of how large the fraction bar is. Usually that fraction bar is a little bit larger than the other ones. So that way you're not worrying about, oh, well, is it 1 over 4/2 or anything like that.
Please excuse the interruption. Will the following students please report to the office? Allison Reed, Alexis Spencer, Aviana Dockey, Anessa Augustine, Selena Cadane, Najee Selby, Ashley Sable, and Khalees Flowers. Please report to the office.
Sorry about that. All right, so we've got this example here. So I have 1/4 over 2, and like I was saying, usually the fraction bar is just a little bit bigger, so you don't have to worry about whether you're doing 1 over 4/2 or 1/4 over 2. So recall that a fraction can also be written as a division problem. So I'm going to rewrite 1/4 over 2, and that's the same thing as 1/4 divided by 2. So now we've done things that are similar to this before. So what we're going to use is keep, change, flip. So you keep the first number the same, change the division sign to a multiplication sign, and you flip the second number. Now, sometimes the first number is a fraction and the second number is just a regular number, an integer. Sometimes the first number is an integer and the second is a fraction. Doesn't matter. You always flip the second number. So whether it's a fraction or an integer, you always flip it. Okay, so you need to know that this KCF, keep, change, flip, is also called multiplying by the reciprocal. Remember, a reciprocal just means that you're flipping something. So 1/2 would become 2 over 1, 3 would become 1 over 3, things like that. Okay? So now I can look at my next problem down here. Josiah can jog 1 1/3 mile in 1/4 hour. Find his average speed in miles per hour. Write a rate that compares the number of miles to hours. So we're comparing miles to hours. That tells us how we need to write our rate. So remember for the last lesson, we talked about rates and unit rates. So this is exactly how it's written in the problem. It tells us to do miles to hours. So miles is my numerator, hours is my denominator. So I can look at this example here. It says 1 1/3, that's my miles, over 1/4 hour, which is what they gave me in my problem. Those are the two numbers that they gave me in my problem. Now both of them are fractions. This is still considered a complex fraction. So I'm going to rewrite the problem in order to make it easier to look at. So 1 1/3 over 1/4 becomes 1 1/3 divided by 1/4. Now to make it a little bit easier, because 1 1/3 is a mixed number, I'm going to change that into an improper fraction. Remember, the way that you change mixed numbers to improper fractions is you take the denominator, multiply it by the whole number, add it to the numerator. Okay? So 1 1/3 becomes 4/3 because I did 3 times 1 plus 1. So now I have 4/3 and I'm dividing it by 1/4. Now we apply KCF. So I keep my first fraction the same, my first number the same. I change my division sign to a multiplication sign, and I flip my second number. Originally it was 1/4, now it becomes 4 over 1. Now I multiply straight across. 4 times 4 gives me 16. 3 times 1 gives me 3. Now I'm going to change this, the 16 over 3, back to a mixed number. You can leave it as 16 over 3, but usually they recommend changing it back to a mixed number. So 16 over 3, in order to do this, I'm going to divide 3 into 16. It goes in 5 times. 3 times 5 gives me 15. I have 1 left over, and my denominator stays the same. So I have 5 1/3. So this means that Josiah can jog 5 1/3 mile every hour. Now you have 3 try it problems, so I want you to go ahead, pause the video now, and try to solve them. All right, now that you've tried to solve these problems on your own, we're going to go over them together. So the first problem I have is simplify the following complex fraction. 2/3 over 7. So I'm going to rewrite it, 2/3 over 7. Now, when I rewrite this, I can rewrite it with a division sign. 2/3 divided by 7. The 7 is the same thing as saying 7 over 1. This is saying the same thing as this. Okay. Now I can apply keep, change, flip. I keep my first number, change my division sign to a multiplication sign, flip my second number. So 7 over 1 becomes 1 over 7. Now I multiply straight across. 2 times 1 gives me 2. 3 times 7 gives me 21. This is already simplified. I cannot simplify it any further because there is no number that goes into both 2 and 21 evenly. So that's my final answer. So I have 221. Okay. Now my second problem says Mr. Ito is spreading mulch in his yard. He spreads 4 2/3 square yards in 2 hours. How many square yards can he mulch per hour? This is asking me for a unit rate. Notice that it asks for square yards per hour. This tells me how I'm going to set my ratio up. So I'm going to set it up for square yards, which was 4 2/3 over 2. I've also included my units. This makes it a true rate. So I have 4 2/3 square yards in 2. Remember, I can always rewrite a fraction with a division sign. So I'm going to do that now. 4 2/3 divided by 2. 4 2/3 is a mixed number. They're not very easy to divide or multiply for that matter. So I'm going to change 4 2/3 into an improper fraction. 3 times 4 gives me 12. 12 plus 2 gives me 14. So now I have 14 over 3 divided by 2, and I can put the 2 over 1. Now I'm going to use keep, change, flip. I keep my first number the same, change my division sign to a multiplication sign, and then flip my second number. Now you multiply straight across. 14 times 1 is 14. 3 times 2 gives me 6. This is an improper fraction and it's not in simplest form. So I can divide both 14 and 6 by 2. When I do this, this gives me 7 over 3, which I can then change back into a mixed number. 3 goes into 7 2 times, so I have 2 with 1 left over and 3 in my denominator. So I have 2 1/3 square yards per hour. The last problem I have is Aubrey can walk 4.5 miles in 1.5 hours. Find her average speed in miles per hour. Again, we're doing miles per hour because that's what it asks in the problem. So I'm going to take 4.5 over 1.5, rewrite it, change both of these because they're mixed numbers into improper fractions. 4.5 becomes 9 over 2. 1.5 becomes 3 over 2. Apply, keep, change, flip. So 9 over 2 times 2 over 3. Now notice that I have 2 and 2. So I can cross simplify these. They become 1. 3 becomes 1 and 9 becomes 3 because I can cross simplify them because 3 goes into 9 3 times. If you don't want to cross simplify, you can leave it like it is and solve it that way. You would get 18 over 6 and then you would have to simplify. If you used cross simplification, you get 3 over 1. 18 over 6 and 3 over 1 are the same things because I can divide 18 by 6 and get 3 and 6 by 6 and get 1. So you get the same answer. So it's up to you which method you would like to use. So this tells me that I get 3 miles every hour. So Aubrey can walk 3 miles per 1 hour.